Welcome everybody, and thanks for joining my talk. And this talk is all about ultra-fast in-memory database processing with Java. So first of all, I have a lot of questions to you. So because this is a conference for not only Java, right? So who of you is a Java developer? Okay, normally you get a t-shirt, but this time we have no Java t-shirts here. That's great. Okay, who of you is a database developer? Okay. Who develops database applications, or works on database stuff in general? Okay. Okay, great. And who has performance issues? Okay. Why are you laughing? So, okay, this is a question for the database vendors, right? Okay. In this session, I will show you how you can build the fastest database applications on the planet. And it's not a joke. This depends on you, what you're doing, which solution you choose. But this is an approach that is not new. It's used by gaming companies, online banking companies already for 20 years. But now we have a framework, and this talk is about how you can use this approach. Here we can see a lot of fancy new applications, applications of the future, so virtual reality, AI, everything is about AI these days, blockchain and so on. And for all of these modern applications, there are some factors super important and critical. Everybody wants high performance, of course. And of course, we want low data storage costs in a cloud. Simplicity is very important for developers. Sustainability is very important for managers and organizations, right? But today, the reality is different. I will show you why. So first of all, some information about myself. My name is Markus, so I work on Java since 20 years or more than 20 years now. With my team, I work on several open source projects. I'm also an organizer of a conference, try to give something back to the Java community, and this is always a lot of fun. So with my company, we are very active in the community. We are a member of the Eclipse Foundation. And most people know about Eclipse Foundation because of the Eclipse development environment, but it's much more. We run more than 100 open source projects under the roof of the Eclipse Foundation. Java Enterprise is now a part of the Eclipse Foundation. It's now called Jakarta EE. And we are also a member of the Micronaut Foundation. Who of you knows Micronaut or uses Micronaut? Okay, great. So this is a microservice framework. We are also contributing to the Helidon project. Who of you knows what Helidon is? Okay, Helidon is also a microservice framework and runtime for building microservices in Java. It's driven by Oracle, but it's open source. Let me talk about database development of today. The situation is a little bit different. So we worked, in my previous project, we worked on a development environment. Based on Eclipse, it should become a Visual Basic for Java. So, and we developed a GUI builder, and everything went fine. So we developed a Swing GUI builder, then a JavaFX GUI builder, then a Vaadin GUI builder for creating HTML user interfaces. The problem we had, as soon as we want to show data on a screen, then everything went bad, slow, complex. So we tried to improve this. So we worked on the JBoss Hibernate tools for Eclipse for almost 10 years now. And we tried to simplify the Hibernate tools to accelerate speed, and we were not successful. Why? It's because there are so many technical problems, and this is my background. So when I talk about database programming, please keep this in mind. So I worked on database stuff, traditional databases for more than 10 years. So it's great. What we have in Java is great, but we have a lot of challenges with these technology. Here's why. Today, database programming is mostly too slow. Performance is too slow, right? So this what's why you were laughing when we talked about performance issues. Database costs in the cloud are mostly too high. So all managers talk about the cloud costs are skyrocketing. And the complexity is way too high, and the systems are mostly not sustainable. And now I want to show you why. And please interrupt me if I tell any nonsense here. So let's have a look on how the database server concept works, actually. So we have an application. Here we have a JVM, and we have memory. We have an application or a microservice, and we have a relational database. Let's have a look inside the relational database, because mostly it seems like a black box. We send an SQL to a database, and we get the result. Great. So when we have a look into inside the database, then we can see there is a lot of memory, right? So, and we have a server, of course. And then we have storage. We have a database management system, and probably there is also business logic running inside a database, stored procedures, stored functions, right? So please keep these components in mind. So storage, computing, a lot of memory, and maybe business logic. What's the problem here? When I came to Java more than 20 years ago, I was stupid enough to ask one question. What's the difference between Java and JavaScript? And the Java developers, they told me, hey, Markus, stop, wait a minute, you cannot compare Java with JavaScript. Okay, yeah, because Java is object-oriented. It's type-safe. That's great, that is super important. So that is what we love, okay? Okay, now I got it. So, but this is important for database programming, keep this in mind. So, everything is great when we do it in Java. Everything is object-oriented, type-safe. Clean code is super important, okay? As soon as we want to store data in a database, then the horror begins, because all database systems on the market are incompatible with the programming language. It's the same in .NET, by the way. And it's the same with all object-oriented programming languages. Incompatible. It's because of you cannot store native Java objects seamlessly in a relational database. This is impossible. So we have some impedance mismatches here, granularity mismatch subtypes. So inheritance is not supported by the relational model. Then we have different data types. In Java, we have some primitive data types. In PostgreSQL, we have around 40 or even more data types supported by the database. So this is always a challenge. The question is, what about the NoSQL databases? Who of you uses NoSQL databases today? Okay, great. So are they better? Don't know. It's because they are different. So the fact is they are very different. What's the difference? So the NoSQL databases now, they introduce new data types, new data structure. This is the biggest difference. The functional principle is pretty much the same. They are also server databases, right? Mostly. So now they introduce key value. They introduce documents like JSON, XML, or a column store, or a graph database like Neo4j. We had the object-oriented databases in the 1990s because initially we want to store objects in a database, so it was obvious to invent object-oriented databases, right? Obviously, it didn't work well. We have time series databases, and now with AI we have the vector databases. Wow. What database should we choose? They are all also incompatible with the native object model of Java. That's fact. They are also incompatible, and that's a challenge. In Java, keep this in mind, we can do everything. We can handle all types. We can store and process all data structure and data types. We can deal with everything. That's great. this is different with databases. They are limited in terms of the use case, right? So, and this leads to big challenges. You can read more about this in the internet or even on Wikipedia. We can find an article about object relational mapping or impedance mismatches. This is how it works. So in our application, we need something additional to store data in a database. We use object relational mapping. So this is a well-known concept and it works great for decades. Who of you uses Hibernate? Okay. Eclipse Link? Okay, cool. So object relational mapping is very common to store data in a database, or job object in a relational database. There are drawbacks. This is super expensive because object relational mapping is very time consuming and it leads to high latencies. So suddenly your queries become really slow. This is what we found out. Is this true? Okay, yeah, you agree. Not always, mostly, sometimes. So we can fix this problem, of course. Okay, let's add a cache. This is what we did in our development environment. So we introduced Hibernate, then it was too slow. Okay, then we added a cache. So, okay, then we have additional complexity. So now we have to deal with cache configurations and so on. But now the results are stored in memory. This will be way faster. We were not satisfied with the performance, actually. And why? Have you ever measured how long it takes to read data from a cache? I grew up with assembly programming, and in today's keynote, we heard about assembly will become, hopefully, more popular in the future when we deal with quantum computing. But when I had a Commodore 64, then I was able to process data in memory in microseconds. When I read data from a local cache with Hibernate, then it takes milliseconds. So I was like, what's the problem here? Why does it take milliseconds when I fetch data from a local cache? Well, the problem is object relational mapping. So obviously, this is super expensive. Okay, then we talked about single node applications. Who of you develops distributed applications? Okay, that's a little bit more complex. Now, here we have an application that runs on multiple machines. What's happening when you change data on one machine? So then the data, the machine will be synchronized with the database. Everything is fine. The problem is all other nodes are not in sync with the database. So this can be a problem. So, but hey, we are developers. We can solve this problem. There is another cache strategy. Let's put the cache in between of the database and the application layer, right? Because we are in the cloud, so we want to avoid a single point of failure, so we use a distributed cache. So we use a cache that is executed on multiple machines. Who uses a distributed cache like Redis? Okay, so very common. Then we have such an architecture, right? So you can see the machines growing more and more. Does it make sense to run a cache without memory? No, it's nonsense. Of course, we need a lot of memory. Keep this in mind. We use memory and we need memory. What about the database? Do we run a database application on a single database node? Probably yes. If the application is mission critical, maybe you will run a database cluster to share the load, data redundancy, and so on. So, and we have a database running on multiple nodes, means there are more machines running. Does it make sense to run a database without memory or low memory? You can do that, but then it will be slow, right? So you need a lot of memory in a database server as well. So now, we talk about an application that runs on multiple machines. Now we deal with microservices. So we split the application in multiple services, and it looks like that. So we have a lot of machines running to maintain, and so this is very common. And then we have a great database, and database is also so fast today, right? So who of you uses Elasticsearch? Okay, why? The database is fast enough. Obviously, sometimes it's not fast enough, so you add another solution, and now you can explain to your managers why cloud computing is so expensive. This is really true. So this is not the case in all applications. Sometimes you have only one solution, or 2 or 3 solutions. And on top of that, we talked about data structure, data types, which means if you want to, let's say you have your Oracle database, and then you need some sensor data, you will have a time series database, probably. Then you deal with vector. Then we have a vector database for AI. So you have, on top of that, multiple database systems running. So this is the reason why database development is super effortful, expensive in the cloud, slow, it's not sustainable actually. So we will produce a lot of CO2 emission and consume energy. Let's wait for quantum computing. See you next year. What's the alternative? Is there an alternative, actually? Yes, it is already. You don't have to wait for quantum computing. So if we change the software stack, and this is not magic, it's actually obvious. Let's have a look how it works. Here is a solution for cheap data storage. When we use a PostgreSQL database, for instance, it's a server database, and this is an example about based on AWS. So you use PostgreSQL as a service, just with 2 CPUs, 8 GB memory, and 1 TB memory. Okay, run it on one node. It will cost you around $4,000 per year, and if you need multiple instances, of course, your price will double, triple, and so on. If you need more nodes, 6 nodes will cost you around $30,000 per year. So the cloud providers, they provide us blob storage or binary data storage like AWS S3. The cool thing here is it costs almost nothing. So 1 terabyte S3 costs only $300 per year. That's great. And I'm not paid by AWS, by the way, right? So you can have the same on Azure or Google Cloud. So there is a solution where we can save a lot of costs in the cloud and look at the CO2 emission. It's almost nothing. And the energy consumption is 99% lower. And you don't have to maintain it. It's managed by the cloud provider. So awesome. So here are some facts about Java. So because on all conferences we talk about, we love Java. So if you attend a Java conference, you will hear this phrase, we love Java. And now let's have a look on why we love Java. It's so fast. Everything that's executed in memory in Java is executed in microseconds. So this is similar to my Commodore 64. And sometimes it's even faster, even nanoseconds, because of our great JIT compiler, right? And we have the best data model on the planet, objects, object graphs. We can deal with all data types, we can deal with all data structure, vectors, JSON, XML, relations, graph, like graph database. Everything is possible. And so this is a multi-model data structure from the beginning. So no limitations in terms of the use case. What about searching and filtering? We have Streams API. With Java Streams, you can search and filter in memory in microseconds. You can compare this with the JPA or a SQL query. Mostly 1,000x faster than a comparable JPA query. So now I will show you a brief demo. So here we have two applications running in parallel. One is built with the JPA stack, so with Hibernate. We have a PostgreSQL database, 250 gigabyte. This is a bookstore application. We use cache, and by the way, it's a hot cache. This is in memory, so we fetch data directly from memory, and on the right you can see the query code. So here we use Spring Data as a framework. The second application is built with Eclipse Store, and we use a blob store like S3, and it is S3, and we use Java Streams to search and filter. So, and all queries are executed sometimes 10 times faster, sometimes 100 times faster, sometimes more than 1,000 times faster than the comparable JPA query. And keep in mind, we fetch data directly from a cache. So with Java Streams, we're up to 1,000x faster than Hibernate cache. This is the performance of Java, and you can improve it even by using, by changing the JVM, for instance. So JVM, you can accelerate in-memory processing by, for instance, the OpenJ9 JVM. It's also an Eclipse project, by the way. It can be 20% more efficient and faster than Hotspot. But you can play around with the different JVMs, so it's incredibly fast. The only thing missing in Java, so what's the problem? The only thing missing in Java was persistence. So how can we now store data on disk? And this is what we have developed at the Eclipse Foundation. This project is not a prototype or just an idea. So it's we have been developing this for more than 10 years. It's production ready. It's in use. It's in production use by companies like Allianz, Fraport here in Germany, and more and more companies are using this framework. It's under Eclipse public license, which means you can use it for commercial purposes free of charge. And there are 4 benefits. 1,000x faster data processing in memory. You save more than 90% cloud database costs, and we do not talk about license fees. It's Java native, which means simple to use. It's fully object-oriented. It's type-safe, by the way. And it feels like a part of Java. This is very important. And because we don't need a database server anymore, just storage, we save 99% energy and CO2 emission, and you develop the fastest application on the planet, and at the same time you save the planet. How great is this, man? So how does it work? So what actually is Eclipse Store? It is a micro-persistence engine. So it is a persistence similar to Hibernate to store native objects. So this is the difference to Hibernate, to store your native Java objects seamlessly to disk and to restore it when needed. That's the functional principle of the framework. Without object relational mapping, without any mappings, without any data conversion, there's no more JSON conversion behind the scenes or something like that. So we really use, and it's the biggest difference, very important, to all databases on the market, no mappings, no data conversion. This is the original Java model is used. Use the original Java object model, and you can persist your POJOs seamlessly into any data storage. it's just a maybe dependency. It's very easy to use. There are the whole framework has only one dependency to the Eclipse serializer that's used behind the scenes. And the only thing you need is an Eclipse Store instance. So this is how it works through runtime. So you need an instance of your data storage in memory. And in memory, it works like a tree. Who of you was a Swing developer? Oh my God. Okay. What about JavaFX? No one. Oh my God. Okay. So we're becoming old. So here are the young Java developers. Awesome. So it works as the functional principle says. A tree works like, so you have a node. So it's the same here with Eclipse Store. You need a node, an instance, a root object, and then you add objects, and all objects that are reachable from this root object can be persisted and stored on disk, right? So this is the functional principle. So I create a root object, add some objects. You can use all Java types. So only Java types that can be recreated can be used and stored. You cannot store a thread, obviously, but all other Java objects you can be used. And then you call a store method, and then a binary representation of your object will be created and stored on disk. So the information is stored in a binary form, and we use the Eclipse serializer for creating the binary and store it on disk. This operation is transaction safe, so you get a commit from the engine, and then it's guaranteed that the object is really stored on disk. So let's add some more objects. We call a store method, and another binary file is created. So, and this is how it works. And each store method, each store operation creates a new binary file in the storage. So it's different to the relational model. So it's a pan-lock strategy. Here's the method call is very simple, just one method to call, and then you can store your objects. As I mentioned, this is a blocking, transaction safe, all or nothing atomic operation. Vice versa, when you start the application, what's happening? When you start an application, then the framework will load your object graph into the memory. You have a question?
Yeah, you said it's a blocking transaction. So is it, if you have multiple threads that are trying to write, only one thread will be writing and the other one is waiting? Or how do you set that?
Okay, the question was how does it work with multiple threads? You can use all Java concepts to handle concurrency, but you have to care for concurrency because so we have to handle this in Java, or we can handle in Java, then you have fully control on which objects and which threads are store the object transaction safe to disk, and you will get a commit from the library.
So that database instance that you create itself is not inherently threads.
You're right. So when we load or when we start an application, then the engine will load the whole object graph in the memory. And now this is, at this point, very important to mention. The object graph informations are loaded. Only the object graph information, which means only object IDs are loaded into the memory. We will not load the whole database into the memory. Only the object IDs are loaded. So you got a kind of like indexed object graph in memory. And then you can define which object references should be preloaded in memory or should be loaded on demand by using lazy loading. So you can have a terabyte, tons of objects in your storage. You have only 2 GB memory. It will work. So it's super easy to define your objects, your classes as lazy or eager. This is just a wrapper class, and then the engine will either preload objects, object references in the memory, or load it when you call the object with a get method. So this is how it basically works. Queries are simple, so because of we use Java Streams API for searching and filtering, and this is very fast. You can check this out. Each query will take only microseconds mostly because of the speed of the Java Streams API memory. The storage will grow more and more, and so this is the reason why there is also a kind of like garbage collector for the file storage. So if we have older objects in the memory, when we change the data model, then we have lazy objects in the memory or corrupt objects, and a kind of like garbage collector process will clean up the file storage constantly and will keep your storage small. So this is the functional principle, and the Eclipse serializer is the heart of this framework. On top of that, we provide an implementation for the JVM. So Eclipse Store is built for the JVM, but there is also an implementation for Android. Who of you is a mobile developer or develops mobile applications as well? No one? Okay. Let's offer a course for mobile developers next year. So what happens if your classes change? So this can be challenging, but it's not in Eclipse with Eclipse Store, because we have a concept. It's called the legacy type mapping, and the framework cares for all of your changes automatically. Or you can also, for complex cases, define a so-called legacy type mapping, and then the storage. Or the legacy objects will be updated through runtime, so you never have to stop your application and refactor the whole storage. This is not how it works. Then we have a file system garbage collector, as mentioned, file system abstraction, which means you can store your data in a blob store, but you can also store your data locally, just on disk. You can store your data almost everywhere, so in any binary data storage. And now this is confusing because of a relational database can deal with binaries. You can even store your binaries in a relational database. But keep in mind, there is no object relational mapping anymore. We just store binary data. There are database connectors, so that you can use an Oracle database. You can use PostgreSQL. Actually, it makes no sense. But in some cases, in some business cases, it can make sense. We had a customer, they used Oracle. They told us, that's a great approach, but we have to use Oracle. Okay, now we store Eclipse Store binaries in an Oracle database. It's possible. And by the way, the Oracle guys do pretty much the same with their graph layer. So they provide a graph database, but it's not the graph database. It is actually a graph API layer on top of the relational database, right? So they store graph information as a binary in a relational database. Then we have a browser, a storage browser, where you can browse through your storage data, and a REST interface, so you can connect can get access to your storage and search and query your storage directly via REST. There are backup functions and converter to CSV, for instance, that you can migrate easy to Eclipse Store or from Eclipse Store to any other database if you like. So it runs with JVM from Java version 11. It runs with any JVM languages on Android, as mentioned already. It runs in containers. It runs in Docker containers on Kubernetes, even with GraalVM native images. And so we talked about single node applications. And this functional principle works also in distributed systems. So For this scenario, MicroStream provides you a platform, a PaaS platform for deploying and running distributed Eclipse Store applications. So we also provide an additional version for even more performance. For with indexing, for instance, then you get out the most speed that's possible. How does it work? So now we can execute an Eclipse application on multiple machines, and the MicroStream cluster provides you data replication, data redundancy. The service is fully managed or available on-prem. There is eventual consistency approach, and this is how it looks like in a distributed environment. So back to our previous architecture, we have a Hibernate application running on multiple machines, a distributed cache, we have a database system. So now we replace the Hibernate applications with the Eclipse Store applications. As we keep and query all data in memory, it is already working like a distributed cache. So, and we store data in a blob store, AWS, for instance, so we can skip the database cluster completely. So, as mentioned, we keep data in memory, we replicate data in memory through multiple JVMs. We don't need a distributed cache anymore, so we can also skip the local cache, and then you can still use your Elasticsearch if you like, but you can also use Lucene, and you don't need a search cluster anymore. So it depends on you. But then the end result is a really small cluster architecture, low cost, super fast, easy to implement and maintain because everything is core Java, and it feels like a part of the JVM. It feels like a part of the JDK. Yes?
You mentioned Lucene. So can Lucene import a Eclipse Store binary? Oh, sorry. You mentioned Lucene. So can you import a Eclipse Store binary file into Lucene and then it will just work?
No, this is not how it works. So you can use and combine Lucene with Eclipse Store as you can use all Java libraries and combine it that are available in the Java ecosystem. But Lucene cannot parse the binaries. So you include Lucene and you will search and filter in memory. And the binary files are only used for storing the object persistently on disk. So you never touch the binary file, right? It's the same with your database server. Your database system will store the data in an internal format on disk. You never touch it, actually. It's the same here. So there are also some rules and challenges with Eclipse Store because so every technology has pros and cons. So there's a comparison. Here's again the traditional database server paradigm. We have an application and we have a database server, and queries are executed on the database server. And the persistent data are stored in the database server, obviously. With Eclipse Store, changes. Now, your database is in memory. You don't have to load the whole database in memory, but it works like the same. So it feels like the whole database is in memory, but it's not. So it's managed by lazy loading by the engine. But keep in mind, your database is in memory. So we search and filter in memory in the application node. And only the data storage, only the storage data are stored in a S3 bucket or something like that. That's the main difference. So you have to think a little bit different. There are no more classic selects you send to a server. You don't use SQL, you use Java streams. And there is no database server where you have a graphical user interface where you have to create a database model. You just have to create classes. That's it. There is no more database model anymore. And again, memory, it means, in memory means, okay, everything executed in memory, so you actually need a lot of memory. And if you have a lot of memory, I showed you how you can save a lot of memory because we don't need a database cluster, we don't need a distributed cache cluster, so we have a little bit more money left for buying a little bit more memory. But if you have not enough memory, you have small memory machines, it will work. So this is very important, but the more memory, obviously, you have, the faster your system will be. The fastest approach you can use, this is not standard, but I like to mention it, and I have updated my presentation because it's so interesting. If you need a way faster approach for really blocking operations, transaction-safe operations with the speed of an asynchronous approach, so with really high write performance, then you can use, for instance, persistent memory. This is super interesting. You just have to add persistent memory to your server. Then all write operations are not directly stored to disk. It's stored in a persistent memory area. It's transaction safe. It takes microseconds to store it and not milliseconds because of disk I/O operation stuff. You can store it in a high performant way. It's like you copy it from one memory area to another memory area, but this area is persistent and provides you persistence. It's called persistent memory. And then behind the scenes, you can synchronize the persistent memory with your disk asynchronously. And this is extremely fast. This just by the way. So, okay, challenges with Eclipse Store. The biggest challenges are you have to think like a Java developer. And Java developers mostly don't think like Java developers in terms of database programming. In terms of database programming, our brain works like a relational database. So if I tell you, hey, please create a database application, I need a shop system, I have customers, I have articles, I have blah, blah, then your brain will create a relational model in microseconds, sometimes milliseconds. So this is why, because we are used to use a relational model sometimes 10 years, 20 or 30 years even, and you have to stop with relational modeling. So create an object model that fits for Java and forget what you have ever heard about a relational model. Forget what you have ever heard about a relational database system, how it works. Focus on how Java works, how you would implement it in Java, and trust the framework will be able to store it. That's it. That's the biggest challenge, to create a proper object model. So it's built for Java developers, so we have no surprises for DevOps and for database admins. So this is the reason why if you have colleagues, they are database admins, probably they will not like it. This is not a drop-in replacement, so please stop dreaming about there is a magic button. I can now replace my Hibernate stack and my relational database with Eclipse Store and it will work seamlessly. This will not gonna happen. And so there is a migration effort and path, but it's doable. It's not complicated, but there is an effort. So keep this in mind. No SQL support, but the application can be created by external services and applications by using GraphQL, REST. So everything here, this is possible, but no native SQL support, obviously. Okay. Conclusion. So, traditional database applications. Sure. Sorry about that. So this approach provides you simplicity. It's because of you can deal with all Java types. There is no more mapping, no more data conversion behind the scenes. It's core Java. There are no dependencies. You can use pochos, and everything can be stored. It can be replicated. You can build distributed applications very, very easily. You will have high performance. So because of the speed of Java, where is my pointer? So all operations are executed in memory with Java streams in microseconds or even faster. So it's suited for low latency, real-time data processing, and so you have really awesome throughputs, and will save a lot of cloud costs because there is no database server anymore. There is just storage, and just storage is more than 90% cheaper than any database server in the cloud. So that's great. And because of there is no more server required, and these numbers are from Amazon, so you will save more than 99% of CPU power, energy, and CO2 emission. And here is also kind of like a comparison. What could be saved if we replaced all database servers with object storage, and so this would be amazing. But this is not going to be happening. This is only in theory. But between 20% to 30%, or probably even more, servers on the planet are database servers, and these numbers are growing because of AI. More and more vector databases are required. We could save a lot of energy and CO2 emission. And if you are interested in learning this approach, I have some gift, because you have to vote me. So, and it's maybe a little bit easier to vote positive for me to enable coming back next year. So I have a free course for you. Yeah. So you can enroll for an Eclipse Store course for free. We provide advanced training and even fundamentals training and for free. So if you're interested, check it out and build the fastest applications on the planet by using Java. Have a great day, and thank you for having me. Thanks, of course.
Thank you, Markus. I'm sure there are a few questions, so I don't know who wants to go first. In the meantime, I ask you something that is more a curiosity from my side. You say, I never have to access directly the storage layer, so S3. I don't care about how you store the data in S3, but I was just curious, if you have 1 million records in your table, do you store 1 million binaries? Is one file? How is structure?
The engine will behind the scenes. The engine will reconfigure the storage constantly and reorganize the storage constantly. So you don't have to care about how does the structure look like in my storage. That's done automatically by the engine. So we have a garbage collector process which cleans up, deletes the legacy objects. You can configure that, and so this is how it works.
Go ahead.
Yeah, hi, thank you. So basically the question is about the use cases. So as far as I understood, you position the solution as a drop-in replacement for DBMSs or for enterprise applications, or just different, or just for embedded applications, or what is it?
Great question. So it is a persistence framework for storing Java objects. This is what we had in mind. to replace Hibernate. So you use Hibernate to store your objects in a database. And use it for almost all use cases. You can build complex enterprise applications, or you just store your tests, or anything that can be stored. You can use it for almost any purpose. It is great for low latency applications where you need real-time speed, really need high speed. That's great to use it for that purpose.
Then the second question, if I may. I'm not a DBA, but I would like to protect the DBMSs. So there's 5 points on the slide regarding the implementation that you will have to do on your application side is, for me, just not fair to mention like something on top of your business logic. So basically, all the stuff, if you know about the Postgres and MVCC, multi-version concurrency control, very complicated thing just that allows you to access to the data storage from multiple applications. Also regarding the tools, so good luck with doing the updates of the like these Java applications. As soon as your I don't know, enterprise application requirements will change. So you have DDL, not only like DML, DDL, and all this high-level abstractions. I'm talking about SQL-like things that allows you to do quite very complicated things just with a few lines of code instead of implementing quite very challenging code on the Java side. So therefore, I mean, do I understand right that this very complicated layer, concurrency, like Benjamin, so we're both working in the same company, so mentioned, so like concurrency thing that is not comparable to this enterprise shit that we just do is very complicated. So does it mean that the application developers, enterprise application developers have to deal with that as well?
This is...
Keep it short, and then we can keep the discussion going on after, because we are unfortunately running out of time. I would love to discuss that much longer. But go ahead.
Obviously, the database cares for concurrency and everything, and you don't have to care for anything. In practice, we see that we have to care for concurrency, and we do it anyway in Java very often. And with microservices, it changes completely, transaction safety and so on. And with Java, we have great solutions for that. So in our perspective, it is not more effort. It is pretty much the same effort. So because mostly you have to do it anyway. But you have to be, so you need experience with concurrency handling in Java. But actually, it's core Java stuff. So there's no new things to learn. This is not like a SQL database. You have to learn a new data model, new query language. It's core Java stuff.